Okay, this next video is going to be on sketching graphs and using the discriminant for quadratic equations. So we're focusing just on quadratics really today. So our title is going to be graph sketching, and essentially we need to think about just our quadratics. So the general term for our quadratic, which we've all seen before, is the idea that we've got some kind of ax squared plus a bx plus a c. And first and foremost, we need to think about the shape of the quadratic. Now, we're used to seeing positive quadratics and negative quadratics. So the key thing about the quadratic is going to be this, well, the highest power is the squared, so the shape of the graph is going to be dictated by the idea that this is a squared as being the highest power. Now, the shape of it is either going to be a smiley face or a sad face. And we've all seen before that the value that a takes, that coefficient of x squared, whatever value that takes, will dictate whether it's a positive quadratic or a negative quadratic. So, essentially, for your notes, we can say that when a is greater than 0, so we can say if a, oops, let me go back to writing. If a is greater than 0, we have a positive quadratic, and it will be a U shape. Okay, similarly, if a is less than 0, we get that N shape, or an inverted U. Okay, so we've got our first indicator as to the shape of the graph, which is going to help us obviously to make that sketch. I suppose it's worth at this point just reminding you that sketching a graph is not the same as doing a table of values and plotting the points. That would be drawing a graph. Here we're sketching, and it should be a much quicker process for us. So first indication is the value of the A. The second thing that we need to think about is where it cuts through the x and y axis. Now, you'll have spent a lot of time before in previous lessons thinking about this plus c value on the end, and it'll have been drilled into you that that is the y-intercept. What we mean by y-intercept is, let's go over here and just draw a quick graph. We might have something like this. The y-intercept essentially refers to, and I think I can do a fancy arrow thing, refers to, look at that point there, where it cuts through the y-axis. I suppose I should label my y-axis, my x-axis. So, when we're dealing with the y-axis, that's quite easy, quite straightforward. We can just see what value we've got in this position here for the c. This position here gives us our y-intercept. Now, effectively, what we're doing in that situation is we're saying, well, x is 0. If we put in 0 for x, this is going to become, substitute in 0, this whole thing would be worth 0. Substitute in 0 here, this whole thing is going to be worth 0. So that leads us to finding out what the y value will be when x is 0. So if we think about that, that makes a lot of sense, because if the x value is 0, if we think about our axis, the x value is 0, which is here, what value of y is going to come out? It's going to be this value here, so we can see that straight from the plus c section at the end. The other bit that we have to be able to, let's get rid of that. The other thing we have to be able to find out is where it crosses the x-axis. So essentially, that is, let's do another arrow, this position here, and can I do 2 of them? Let's try. Oh, yes, this position here. So we're interested in now where y is equal to 0. So we're not going up here, we're not coming down here. We're interested in y is 0 equals 0, what x values come out. So in order to do that, we need to set our equation equal to 0. So let's go back to our notes. Okay, so this was the first point we had to do. The first thing was here. Second point is finding the x and y intercepts. So I'm going to actually write that for your notes. Let's make it a bit easier. finding the x and y intercepts. And we do this by setting x equal to 0 and setting y equal to 0. So we set x equal to 0 and we set y being equal to 0. Now it's quite intuitive, I suppose. We're used to setting x equal to 0 and just reading off that plus c value. Now if we, oops, didn't mean to just move that. Let's see if I can stop that happening. I think it's that one, yeah. Okay, so we set x equal to 0 or set y equal to 0. Now, what's quite interesting is when we set y equal to 0, we're used to solving an equation, finding out where the roots are. Now, if we go back to a graph, and if we think about our, get rid of this one, get rid of this one, and also I'm going to try and get rid of, no I can't, right, let's start again then. So, our axis looks like this. Now, if we think about our usual quadratic shape, so let's just say we've got that positive quadratic, we've got that U shape, that smiley face, and we're trying to find out where it cuts through the x-axis, where our roots of our equation are. So there's different scenarios that could arise. We could have that positive quadratic, and it might be up here somewhere. Let me get my pencil. Up here somewhere, and it might come through here and give us our y-intercept. Now in that situation, there's no roots to that quadratic that I've just drawn there. If I draw a red one, it's possible also to have a single, what we call repeated root, where it just kind of kisses the axis, or did I make it touch? Just about, and goes back up. So there's only one point really, doesn't look the best there, but there'll be one point there where we have a repeated root, which is a single root, and then finally in blue, we could have one of our usual ones that provide us with two roots. So a quadratic can have 0, one repeated root, or two roots. And that is closely related to, or closely linked to the discriminant, which is what I'm going to just talk about now, which is something that we need to be aware of as we move forward. Okay, so moving back, first of all we worked out our general shape, secondly we're finding the x and y intercepts, and the final thing that we're going to have a go at is just considering our discriminant. So, number 3, we are going to consider our discriminant, and I'm going to talk you through exactly what that means. So, let's consider our discriminant. Okay, so we're considering our discriminant. Okay. So, what is the discriminant? It's derived from our quadratic formula. You know, when you're unable to factorise an equation, you reach for that quadratic formula, the one that we all should be able to repeat back, that minus b plus or minus square root of b squared minus 4ac all over 2a, which we're quite used to seeing. Now, wow, look at that, quadratic formula, nice and neat. Okay, so, if we look at our quadratic formula, and we look at this section here, this is the bit that we're interested in terms of our discriminant, and that will give us our indication as to whether we have a single root, two roots, or no real roots. Now, that's interesting because of the fact that it's under a square root sign, which restricts the kind of values that we can get coming out. Obviously, we're quite happy, we're comfortable with square rooting our numbers, square rooting, say, 9, we get an answer plus or minus 3. Now, if we square root 0, the only answer we can get out is 0. And if we square root a negative number, that's going to give us a math error. We're not able to give a defined answer for that, so that's not going to give us any real roots for our equation. So, our discriminant, this b squared minus 4ac inside this square root, if that gives us a positive, a negative, or a value of 0 coming out, that's what's going to dictate whether we have 1, 2, or no real roots. And let's just summarise that and get the notes down for that. So, if b squared minus 4ac is greater than 0, as in it's a positive number, we say that we've got two real roots. So there'll be two distinct different roots. So we can write in our notes b squared minus 4ac, if that's greater than 0, we have two real roots. just about fit this in. Okay, now, if we say that b squared minus 4ac is equal to 0, then we say it has one repeated root. So, one repeated root.
You're welcome.
Which was the situation we came across earlier, where it just kind of touched the graph. So up here somewhere should be our graphs. Oh no, I got rid of them. Well, it would look like this, and it would just touch the graph and then go back up. So just one, it doesn't go through. Okay, going back down, the final situation, that b squared minus 4ac might be less than 0. Now, if that's the case, if we think about our discriminant, what we're going to be doing is we're going to be square rooting a negative number, which isn't possible. So what we say here, our graph doesn't get as low as the x-axis effectively if we're visualising it, but what we say here is there are no real roots. So we can just write next to that, no real roots.